So we have another problem, example 7. So it's an inequality. We want to solve it, graph it, and write the interval notation. Okay, so it looks like we've got some distributing to do. For b, it's going to be minus 9. So I'm taking that negative 3 times 3 is negative 9. And then a negative 3 times a negative b, it's going to be plus 3b. So again, we're kind of reviewing these steps. So make sure we get that that's a positive 3b. Greater than, and then I've got to distribute this 5. It's going to be 5b minus 30 plus 2b. All right, so on the left-hand side, I'm going to have 7b minus 9 is greater than 7b minus 30. Now this one's going to be interesting. Okay, so I have a 7b on the left and I have a 7b on the right. Well, I'm going to go ahead and subtract 7b from both sides. I think it'll be easier to show you what's going to happen. So I get negative 9 is greater than negative 30. All right, so in this situation, I've lost the b. So I've lost my variable. So what it means is the statement's not true or false dependent on the value of b. It's just either always true or always false. It's either an identity or a contradiction. So is it true? Is negative 9 greater than negative 30? Yes, this is true. And so what does that mean? It means all real numbers work for this inequality. So whatever value you put in for b, it's going to always make a true statement. And so we want to say this solution is all real numbers. Now, how do we, I'm going to write that, all real numbers, but I'm not putting a box around it. Okay, because it asks us to graph it, and it says to write the interval and the solution in interval notation. So I want to show you how to do that. For the graph, here's 0, and the graph is going to be all real numbers. So, you know, it's the whole real number line. That says all real numbers, okay? That's the graph. Now, what does the interval notation look like? It goes from negative infinity to infinity. So this means the solution is all real numbers. And that's what we're going to be looking for with that interval notation. So this comes up on the future lots of times. We want to represent all real numbers, and so we do that with a negative infinity to infinity. Now, I'll try to read your mind here a little bit. So what if it had not been true? What if it had been false? Then it would have been a contradiction. Let's see if I have a little room. So new problem. Say you had x plus 3 is greater than x plus 5. And so you're like, oh, okay, I'll subtract x. Then you get 3 is greater than 5. Well, that is not true. And so it's never going to be true for any value of x. So there's no solution. Sometimes some textbooks will actually write no solution. But for our purposes, the graph, you would just draw a number line. You wouldn't put anything on it. And then for the interval notation, we just write the empty set. So that's still acceptable. But I thought maybe you might have that question, so I thought I'd show that. Okay, now watch that happen on the next one. All right, we've got a bunch of fractions in here. And so this video was titled Clearing the Fractions. So we're going to clear the fractions. So what's the smallest number? What's the LCM of 4, 12, 6, and 8? What's the LCD here? I'm going to say 24. All those numbers will go into 24. So I'll show you a little trick here on this problem. So you can use this on equations as well. So write it out a little bit with a little bit more room. And then I'll use a different color. I'm going to multiply each term by 12. So multiply by 12, multiply by 12. I'll just kind of squeeze it in here. Now that takes care of the distributing for you. So you don't have to write it with 12 on each side and then distribute it. It kind of takes care of it in one step. So that helps a little bit. All right. So now we can do the canceling. How many times is 4 going to 12? 3. 12 and 12 cancel. 6 goes into 12 2 times. Oh, dang it. It was supposed to be a 24. Well, I'm going to salvage this. I'm going to rewrite it. Sorry. We all make mistakes. I don't know where I came up with 12. I guess I looked at the 12 and said 12. But it was supposed to be 24. We already said it was going to be 24. You're all there watching your screen going, why did she put a 12 when it was supposed to be a 24? Okay, so let's try a 24 now. It's going to change things. Same idea though. I think I was excited to show you the trick. Okay, so now we're back to where we're supposed to be. So the 24, 4 goes in, now we'll do the canceling. 4 goes into 24 6 times. 12 goes into 24 2 times. 6 goes into 24 4 times. And 8 goes into 24 3 times. Okay, so now what do we have after all that mess? We've got 6x, 6 times 1 times x, minus 2x, 2 times 1 times x, is greater than 4 times 1 times x, which is 4x, plus 21. That's what we were looking for, was that 21. Okay, so 6x minus 2x, 4x. It looks suspicious, doesn't it? Okay, subtract the 4x from both sides. That's what we would try to do, try to get x on one side. So the 4x cancels on the left, so we just have 0. That's what you do when that happens. 0 is greater than 21. Sure enough, this is like the problem I was just talking about. Okay, so 0 is greater than 21. No, that is false. There's no solution. You can write that. I'm not going to write that as my answer. I'm not going to put a box around it, but sometimes it helps to kind of write these things out to get your mind wrapped around it. All right, graph. Well, here's the number line. Plain number line without, you can put like little marks on it if you want. 1, 2, 3, 4. But we're not going to graph anything on it because there's no solution. And we're just going to write the empty set symbol. Okay? All right.